Hello students. We will be discussing today current electricity chapter. In the previous video we discussed electrostatic potential and capacitance, and now today we are going to discuss the topic of current electricity. So we will be covering a majority of the concepts and some questions also based on that, and we will be doing some questions based on series and parallel combination of resistors also. So let's start. So the first concept is basically related to what? The first concept is related to the definition of current. So when we define current, please understand, whenever we define the value of current, what actually happens is that electric current is the time rate of flow of charge through a given cross-sectional area. So very simple definition. Suppose you are having a cylindrical cross-sectional area, and let us suppose the area of the cross-section you are taking it as A. Then if in dt time some dq amount of charge flows through that area, then the current will be given by I is equal to dq by dt. Now here there are basically two types of current. One is average current and one is instantaneous current. When we talk about average current, then the average current will be given by total charge flown divided by total time taken. In delta t time, let us suppose delta q amount of charge flows, then what will be the value of average current? It will be delta q by delta t. And if you talk about instantaneous current, then the instantaneous current will be equals to what? The instantaneous current will be equals to dq by dt. So for instantaneous current, let me write. For instantaneous current, I will be equals to dq by dt. So instantaneous current is the current at a particular instant of time, and average current is the current in a particular interval. So this is basically the definition of instantaneous and average current. Instantaneous current and average current have unit amperes. The unit of this particular current is amperes. It is a scalar quantity, and the direction will be always along the movement of positive charge or opposite to the flow of negative charge. So always remember, the direction of current will be in the direction of flow of positive charge or opposite to the direction of flow of negative charge. Remember one thing, actually positive charge does not flow. In the actual sense, in the conducting wires, the electrons only flow. But by convention, if you take instead of electrons, you take an equivalent positive charge also, then also there will be no problem. You can definitely use the convention of flow of positive charge for the definition of current. But remember one thing, even though current has direction, which is the direction of flow of positive charge or opposite to the direction of flow of negative charge, even though it has direction, but still it will not be considered as vector quantity. Because for considering any quantity as a vector quantity, always remember that it should follow the laws of addition, the vector laws of addition, either parallelogram law or triangle law. But here this current is not following the laws of vector addition. Like if you see here, in this case what is actually happening is that one current 3 ampere is going, another current 4 ampere is going, the total current will be 7 ampere only in the next wire. So here we have just used the basic algebra, the basic scalar addition we have used. We have not used vector addition here. That is why if somebody will ask you that is the current scalar or vector, so you will say that the current is a scalar quantity, but it has direction. Understood the logic? Okay, so this was all about the concept of current. Now let's go to the next concept, that is current density. What is current density actually? Current density is basically the current crossing per unit area of cross section. And always remember, whenever you take that area of cross section, that area should be perpendicular to the direction of flow of current. Only that area you will take which is perpendicular to the direction of flow of current. Like in my example, if you see here, this particular conductor is there, cylindrical straight conductor. I have taken a small area A here, and this particular area current is flowing perpendicular to this area. So I will say that the current density will be current divided by area, I divided by A. And what will be the direction of current density? The direction will be basically in the direction of current. Wherever the current is flowing, in that same direction, the current density will be there. So it will be given by I by A into n cap. N cap is a unit vector along the direction of current. Suppose if my area is not perpendicular to the flow of current, suppose the area is like this. What I am trying to say is, let me tell you on the next page. Suppose if the area is like this, and the current is flowing like this. In that case, what I have to do is, we have to think about area vector. So area vector will be in this direction. In electric charges and field, we already discussed that area is a vector quantity, and its vector and its direction will be perpendicular to the surface of the area. So area vector will be in this direction. Let us suppose the angle between this current and this area vector is theta. So if you see properly, if you resolve this particular area, if this angle is theta, this angle will also be theta. So this area, the perpendicular area which is perpendicular to the current, will be A cos theta. So in this way, what will be the value of current density? Current density will be current divided by the perpendicular area, which is A cos theta. And you can also write current as J into A cos theta, which can be written as J vector dot area vector. So basically what I am trying to tell is that if you will go for, please understand carefully, if you will go for this area, then in that case current can be written as the dot product of current density and area vector. One more thing, if your current density is not uniform, see this formula you can only apply when the current density is uniform. If the current density is not uniform, then in that case the current can be written as integration of J vector dot dA vector. So you have to integrate it over the surface, and then this will give you the value of current through that particular area of cross section. So I hope this particular concept is clear to you. And we have also discussed one more thing, that I average can be written as delta Q by delta T, and instantaneous current can be written as dQ by dt. Suppose if you want to find the charge flowing through a particular time interval, then you can integrate it. The total charge flowing through the interval will be integration of 0 to t I into dt. I hope this particular concept is clear to you. So whenever charge as a function of time will be given to you, to find the current you will do dQ by dt. Whenever current as a function of time will be given to you, to find the total charge flown, you will do integration of I dt from 0 to t. So suppose I have given a question here that Q is equal to t square plus 4t plus 12, and they are asking you to find the average current in 2 seconds and current at t equals to 3 seconds. So let me discuss it on this particular page, that charge is given to you, please understand, charge is given to you as t square plus 4t plus 12, t square plus 4t plus 12. And in the first case, they are asking you average current in 2 seconds. I told you to find the average current, what we have to do? To find the average value of current, we have to just go for final charge minus initial charge divided by total time taken delta t. So what is the final charge? You have to calculate, put t equals to 2 seconds there. So t equals to 2, if you will put, your final charge will come out to be 4 plus 8 plus 12. So this will be 12 plus 8, 20 plus 4, 24 coulomb. And at t equals to 0, what is your initial charge? Initial charge is nothing but 12 coulomb. So basically the average current will be equals to 24 minus 12 divided by 2 seconds. This will come out to be how much? 6 ampere. This will come out to be 6 ampere. And if you want to find the instantaneous current, they were also asking you to find the instantaneous current at t equals to 3 seconds. Then how you will calculate? For instantaneous current, you will differentiate it. So I will be equals to dq by dt. dq by dt, if you will do, you will get it as 2t plus 4. And at t equals to 3 seconds they are asking. So current will be equals to 2 into 3 plus 4. That is 3 into 2 is 6 plus 4. That is 10 amperes. So 6 ampere and 10 amperes are the correct answers. So basically this is how you can calculate the current instantaneous or average. So 6 ampere and 10 ampere are the correct answers. I hope it is visible to you. So this is basically the concept of current. Let's move forward. So in the next case, we will discuss one more question. So first question was when I was telling you to find the current if charge as a function of time is given. But in this question, if you see, current as a function of time is given. Current is given as 3t square plus 2t plus 2. And they are asking you to find the charge flown. They are asking you to find the charge flown in 2 seconds. And they are asking you that take the initial charge to be 0. So if charge is flowing in 2 seconds, how you will calculate? It is very simple. We know that current is basically equals to what? Current is basically equals to dq by dt. So current will be equals to dq by dt. So what will be the charge which will be flowing in this particular time? The total charge will be flowing is integration of I dt from the given time interval, whatever time interval is given, suppose 0 to t you are asking. So integrate the current as a function of time and you will get the total charge. तो कैसे कैलकुलेट करेंगे? हाउ वी विल कैलकुलेट? प्लीज अंडरस्टैंड. So in this particular question, the dq, the total charge will be q final minus q initial. That will be the integration of current from 0 to whatever time is given, 2 seconds is given. Integrated, you will get the value of charge flown, and final charge will be equals to 16 coulomb. So this is how you can calculate the value of charge. So if charge as a function of time is given, find the current. If current as a function of time is given, find the total charge flown. Now, next concept is the concept of relation between current and velocity of charge carriers. Okay, so here I have given some basic points of conductors. There is no need to learn this, we already know. Let me explain you in detail. Conductors carry large number of free electrons. Free electrons means what? They are basically charge carriers which are not bounded to the nucleus, and they are free to move in the lattice of the metal. So basically free electrons are what? Which are the valence shell electrons which have gained enough energy, so they are in the lattice of the metal and they can move freely and they can conduct electricity. So the materials which can conduct electricity are called as conductors, and the materials which do not have these free charges, the charges are mainly bounded, are called as insulators. In the capacitance chapter, you remember we discussed dielectrics. Those dielectric materials are basically called as insulators. Okay, so basically what happens is whenever there are charge carriers which are moving with some velocity, I want to find how much is the relation between the current and the velocity of charge carriers. So how will I calculate? See, derivation is not important, just you have to remember the result. Result is more important right now compared to the derivation. So directly I am giving you the result. The result will be that current will be equals to N into A into V into Q. Please understand, the current will be equals to N into A into V into Q. N into area into velocity into the magnitude of charge. Suppose Q charge is flowing, so V will be the velocity of the charge carriers, Q will be the magnitude of one single charge, N will be what? N will be number of charge carriers per unit volume. So basically this is called as free charge carrier density. So number of charge carriers per unit volume will give you the value of N, and in this way the current will be NAV into Q. And one more thing, since you already know that current density is basically what? Current density is basically current per unit area. So if you will divide this equation by the area, you will get N into V into Q. Or vectorially I can write current density will be N into Q into velocity vector. Because these are positive charges, I am assuming right now this is a positive charge. So current density will be in the direction of flow of positive charge only, because I know that current density is in the direction of flow of current. So basically J vector will be given by NQV vector. I hope this concept is also clear to you. This is the relation between current and velocity, and the relation between current density and velocity of charge carriers. Chalo, let's move to the next concept. The next concept is motion of free electrons in a conductor. What actually happens whenever there is a conductor, and how the free electrons are moving in a conductor? So please understand, very simple to understand, and from here you will get the concept of drift velocity. Please understand carefully. What actually happens is, whenever there is no potential difference applied across the ends of the conductor, in that case the free electrons in the conductor move in the same way as the gases move in a container. The gases do random motion, randomly they go here and there. The average velocity of the average thermal velocity of the gases is 0. In the same way, the average thermal velocity of the free electrons inside the conductor is also 0. And why this is happening? Because the electrons are actually moving in the random directions. So if you take any cross section of the conductor, there is a very high probability that whatever electrons are crossing in this part, the same electrons will be crossing opposite to this. So average velocity will be 0. So even though the electrons are moving with very high speed, very high thermal speeds it has of the order of 10 to the power 6 or 10 to the power 5 meter per second, then also they are not able to constitute the current, because for current to be there, the charge carriers should flow in a directed manner. They should not move randomly. So this is what is written here, that the average thermal velocity of the electrons, of the free electrons, will become 0. And this average thermal velocity is basically due to what? It is basically due to the temperature of that particular conductor, or heat developed due to the conductor. So that is because of which the current is not there. Why current is not there? Because random motion is there, they will cancel out each other. Now what happens is, if you want to flow current, if current has to flow in a particular wire, then you have to apply a potential difference across the two ends, and that potential difference will be provided by the battery. So basically, whenever you will apply a potential difference across the two ends of the conductor, now the directed motion will start and the electrons will start drifting from where to where? They will start drifting from the lower potential to the higher potential. Why it will happen? Because the battery has provided a constant potential difference here. So here the potential is V, here the potential is 0. The electric field inside the conductor will be from higher potential to lower potential. Because of this electric field, the electrons will experience force opposite to the direction of electric field, and they will start drifting from lower potential to the higher potential. Or if you want to answer this question in terms of positive charges, then the positive charges will start drifting from higher potential to lower potential. This velocity with which the electrons drift inside the conductor because of the electric field presence, this particular velocity is called as the drift velocity of the conductor or of the free electrons. So basically the drift velocity comes out to be how much? The drift velocity comes out to be minus of E vector divided by m into tau. Again, I am not doing the derivation. Derivation is not important right now. We just have to quickly brief our concepts. You already might know how to derive this result, but main concept is that your derivation, your formula should be clear. So drift velocity will come out to be how much? मैं लिख भी देता हूँ. Let me write it here. Drift velocity will come out to be equals to minus of E vector divided by m multiplied by tau. Let me tell you the logic also, which represents which. So drift velocity here, E is the charge of the electron, m is the mass of the electron, E is the electric field which is applied because of the potential difference of the battery, tau is the relaxation time. What is the meaning of average relaxation time? Basically what happens is that when you will apply an electric field, the electrons will start drifting. But what will happen is the electrons will collide with other electrons after some time, or they will collide with the ions of the metal or of the conductor. So average relaxation time is basically the time interval between two successive collisions. Suppose the electron collided at t equals to 0 with some electron or with some ion, then after how much time it will again collide with another material of the ion. That particular time interval is called as the mean relaxation time or the average relaxation time, which is given by tau. So drift velocity comes out to be, this particular formula comes out to be for drift velocity. What is the significance of minus sign? Negative sign is telling you that the drift velocity of the electrons is opposite to the direction of electric field. And this is happening also because I am assuming that the electrons are moving, and electrons will always move opposite to the direction of electric field. So that is why this negative sign is coming. So drift velocity is the average velocity with which electrons drift under the action of external electric field in a conductor. I hope this point is also clear to you. Let's move to the next part. Now, how to develop current in a conductor? Please understand, there is a relation between the current and drift velocity also, because just now I told you in the previous slides that basically if charge carriers are drifting in a particular direction, then the current will be constituted, and that current and velocity have a relation. We developed that relation, and that was coming out to be NAVQ. So in the same way, if you take current in a conductor, suppose you have a conductor, cylindrical conductor, and its area of cross section is given as A, length is given as L, and you have applied a potential difference V across this conductor. So the electric field developed here, will be equals to how much? Electric field will be equals to potential difference per unit length. Here N is what? Here N is basically the free electron density and A is the area of cross section. So N is the free charge carrier density. Here the charge carriers are basically electrons. So N is the free electron density and A is the area of cross section. So basically what will be the value of current? Current will be equals to NAQ into V. And because here Q is replaced by E because we are talking about electron, and V will be replaced by drift velocity. Now if you will put drift velocity here, what you will get? Please understand. If you will put drift velocity here, current will be equals to NA into E multiplied by drift velocity magnitude wise will be EE upon M multiplied by tau. So from here you are getting the result. That current is NE square A by M into tau into E. E can be written as V by L. Final result which you are getting is that V is equal to m upon NE square tau L upon A multiplied by current. So now please understand that I have got a very important relation, that the voltage, the potential difference across the conductor is equal to some constant. That constant is called as resistance multiplied by current. Very important result. We have got the scalar form of Ohm's law. We have got the scalar form of Ohm's law, that potential difference across any conductor which is having some property which is called as resistance of the conductor will be equals to resistance multiplied by the current across the conductor. And what is the value of this resistance? This resistance is basically m upon NE square tau into L divided by A. This is basically the resistance of the material of the conductor. This is written here, m upon NE square tau L upon A. I hope it is clear to you. It is a scalar quantity and it is basically, the unit will be volt per ampere, that is given as ohm. Always remember, for a particular material at constant temperature, the resistance will be a constant value. It will not depend on the voltage and the current of the conductor. For a particular material at a constant temperature, the resistance of the material will be equal to V by I. I hope this entire concept is clear to you. Now I will introduce one more quantity, that is resistivity of the material. M upon NE square tau is itself a property of a material. So that particular property is called as resistivity. So R will be equals to rho L over A. A very important formula again. We have got one more formula, that the resistance can also be written as rho L divided by A. L is the length of the conductor, A is the area of cross section, rho is the resistivity of the material. What is the difference between resistivity and resistance? That also let me tell you. Resistivity, if you see, it is basically m upon NE square tau. Resistivity is only depending on the nature of the material, because relaxation time will depend on the nature of the material. N will also depend on the nature of the material. So these two quantities depend on the nature. So resistivity will depend on the nature of the material. Resistivity will also depend on the temperature of the conductor. If you change the temperature, these quantities will change. But resistivity does not depend on the length and area. That means it does not depend on the geometry of the material. On the other hand, the resistance actually depend on this length and area. So resistance will depend on the geometry of the material. If you bring two conductors having different shapes and sizes, the resistance of the conductor will change, even though it has same material. But the resistivity of the material will not change. I hope it is clear to you. So this is basically the concept of resistivity and resistance. One more thing, resistivity will have a unit of ohm meter, and this is also a scalar, and this I already told you that it depends on the material and the temperature. Okay, so one more property I am linking here. There is one more property which is called as conductance, and conductance can be written as basically what? Conductance can be written as 1 upon resistance. The unit will be ohm inverse or mho or Siemens. Okay, so conductivity, and one more property is there, that is called as conductivity. Conductivity is basically reverse of resistivity. So please remember, if you reciprocal the resistance, you will get conductance. If you reciprocal the resistivity, you will get conductivity. So conductivity is denoted by sigma and conductance is denoted by S. Conductivity will be NE square tau divided by M, and basically current will be equals to what? यहाँ पे मैं relation बता रहा हूँ, please understand. We already knew all these things. So from here we can get one more relation, that current density can be written as conductivity multiplied by electric field. तो ये भी बहुत important है यार. This also is very important relation, that J vector is basically equal to sigma into E vector. This is also a very important relation which you have to remember. This is sometimes called as the vector form of Ohm's law. Please remember this result. Derivation I am skipping somewhat because time is limited. So J is equal to sigma into E. Sigma is conductivity, E is the electric field applied, and J vector is the current density of the material. I hope these points are clear to you. Let's move forward. Now, some type of questions come in which they will give you basically a material, they will give you a conductor in some different shapes, and they will ask you to find the resistance of that particular material. So how you will find? Very simple. Suppose they have given a cuboid. Achha, first let me tell you one thing, that whenever you will apply this formula, R is equal to rho L over A, then please understand that L will be the length along the direction of current. If there is a current flowing in any particular direction, then in whatever direction current is flowing, you have to take the length in that particular direction. and A will be what? A will be cross-sectional area perpendicular to the current. So suppose there is a conductor, A is the cross-section area perpendicular to the current. So perpendicular to the current, whatever area is there, that you have to mark it here. Okay? So let me take one example. Suppose there is a cuboid, you might be seeing this. Suppose there is a cuboid, the length is L, the width is W, and the height is H. And you are required to find the resistance across these two ends, point 1 and point 2. So resistance across 1 and 2 means what? That you will apply a potential difference across these two ends. ये potential difference आप apply करोगे. So obviously the current will go along the length of the wire. So this will be the length and the area will be this particular part. So this part area will be how much? This is W and this is H. So area will be how much? W into H. So this is how you will get the resistance. In the same way, you can find the resistance between 3 and 4 also. If the current will go from here to here, then the length will be equals to H and the area will be this area and this area will be given by W into L. So this is how you have to find the resistance. So please remember this result, rho L over A, that is a very important result. I can take one more example. Please understand. I can take one more example. Suppose this is a concentric cylinder. Inside there is no material. The inner radius is given as R1 and the outer radius is given as R2. And I want to find the resistance across these 2 points 1 and 2. So what will happen? Obviously the current will go in this direction only, na? The current will go in this direction only. So length will be nothing but L only. But on which area it is going? Basically, if you will see the area of cross section will be this only, na? This is the bigger area and this is a smaller area. The material is only in this part and this area is nothing but how much? This area is basically pi of R2 square minus R1 square. So area of cross section will be this, length will be this, so resistance will be rho L divided by pi R2 square minus R1 square. I hope this particular formula is also clear to you. No need to do this particular question. For NEET it is not that much important, but these type of questions can come. Okay. Next comes Ohm's law. We already know the concept of Ohm's law. I already told you. Let me just give you the statement of Ohm's law. The statement says that the voltage across a resistor is directly proportional to the current in the resistor and at constant temperature and external conditions. If the external conditions such as pressure, temperature and all these things are kept constant, then the current in the conductor will be proportional to the potential difference across the conductor, and that particular linearity will be given by delta V is equal to IR. So please remember one thing, whenever you are having a ohmic material, what is ohmic material? Ohmic material is the one which follows Ohm's law. The materials which follow Ohm's law will be called as ohmic conductors. For ohmic conductors, delta V will be proportional to the current. So delta V is equal to IR you can apply. For non-ohmic conductors also you can apply delta V is equal to IR at a point, but the relation between delta V and current will not be a linear relation. It can be any other relation also. So this is the difference between these 2 points which I want to tell. Achha, one more thing. Whenever you are having a resistor, this is how you represent a resistor in a circuit. So whenever you are having a resistor, then obviously the current will always flow from higher potential to lower potential across the resistor. So how will you write the current? The current will be written as, let me write it here, the current will be written as the potential difference. Since it is going from V1 to V2, V1 is greater than V2, so I will be equals to V1 minus V2 divided by R. So based on this, some simple questions are there. What are the questions? Please see. Suppose I have taken this question. Resistance is given as 5 ohm and current is going from here 6 ampere and it is going towards 50 volt. तो कैसे लिखेंगे? How we will write? बहुत easy है. It is very easy to understand. We will write V minus 50, that is potential difference, is equal to I into R, that is 6 into 5. So V will be equals to how much? 50 plus 30, that will be equals to 80 volts. So V will be equals to 80 volts. So if you remember the basic concept of Ohm's law, you will be able to do these particular questions. So let's move forward. Let me come to the next concept. ठीक है. Here also please understand, and this will be the relation between delta V versus I. That means if you will take Ohm's law, then delta V will be proportional to the current and that slope will give you the resistance if you are plotting voltage on the y-axis and current on the x-axis. If you plot current on the y-axis and voltage on the x-axis, then the slope will be 1 by resistance. This you have to be careful about. Acha, one more thing. Whenever you are having a wire of length L and they will ask you to stretch the wire, and make the wire double, or they will ask you to compress the wire and make the wire half of the length. In those cases, always remember volume will always remain constant, and if the volume is constant, then resistance will be proportional to L square, or resistance will be inversely proportional to A square. So please understand one thing, that whenever these type of questions will come, that there is a wire which is given to you, you are stretching the wire or you are compressing the wire. In all these cases, the resistance basically will be depending on proportional to L square or inversely proportional to A square. Understood the logic or not? Their resistance will not be proportional to L because their area is also changing. Volume remains constant. So in those cases, you can apply this particular result. Now comes dependency of resistance on temperature. How resistance depends on temperature. So please understand one thing. Again, I am not deriving it. I will give you the final result. Please understand, whenever we are talking about the temperature dependence of resistance, so it depends which material we are talking about. If we take conductor, in the case of conductor, if temperature will increase, the resistance will also increase. In the case of insulator or in the case of semiconductor, if the temperature will increase, the resistance of the material will decrease. And there are some materials like this also, like nichrome, some alloys are there, nichrome, constantin, manganese, in which the even though you increase the temperature, the resistance of the material does not change much. Then there is a material gallium arsenide also, which is a semiconductor, which follows a non-linear relation of voltage versus current. It is a non-ohmic conductor and it sometimes shows negative resistance also. So when I talk strictly about conductor, then for conductors or for semiconductors also, the relation is given by delta R is equal to, approximate relation it is, delta R is equal to R naught into alpha into delta T. Delta R means R final minus R initial will be equals to R naught, R initial is basically R naught into alpha into delta T, alpha into delta T. So this relation you can remember. This is an approximate relation, always remember. The actual relation will be R is equal to R naught e to the power alpha delta T. It is an exponential relation. Even if you will plot the resistance versus temperature difference for a conductor, you will get it an exponential relation. But if you will do the approximation, we will get this relation as R final minus R naught is equal to R naught alpha delta T. Here please remember, alpha is called as the temperature coefficient of resistance or resistivity. And R naught is the resistance taken at reference temperature. That reference temperature in many standard books is given as 0 degree Celsius or 20 degree Celsius. So R final minus R naught will be R naught alpha delta T. R naught can be written as the reference particular temperature. Understood the logic? The resistance at the reference temperature will be given by R naught. And if you want to find the resistance at any other temperature T, then you can find the resistance by giving this formula. I hope this particular concept is clear to you. Like, let us suppose if you take this particular concept in which at 0 degree Celsius the resistance is given as 20 ohm and the wire is having alpha of 10 to the power minus 4 per degree Celsius, then you have to find the resistance as 20 degree. So you can apply this particular formula and first of all check whether alpha delta T is much lesser than 1 or not. If alpha delta T is equal to much lesser than 1, then you can apply this approximate formula. If alpha delta T is not smaller, then you have to go by the actual formula. But in NEET classes, generally this particular formula is not required. Generally, whatever data they will give you such data that alpha delta T is much lesser than 1. You can directly apply this formula and get the answer. I hope this concept is also clear to you. So let's move to the next concept and let's talk about now the concept of electrical power. Okay, these questions are also given to you. Let me dictate you these questions also. The resistance of a platinum wire is 5 ohm at ice point and 5.5 ohm at steam point. Ice point means what? Ice point means 0 degree Celsius. Steam point means 100 degree Celsius. So at 0 degree Celsius, the resistance of the wire was 5 ohm and at 100 degree Celsius, the resistance of the wire was 5.5 ohm. And they are asking when the wire is inserted into a hot tub, then the resistance of the wire is 5.8 ohms. So you have to find the temperature of the tub. So again I will use the basic formula, R is equal to R naught 1 plus alpha delta T. So at 0 degree Celsius, R naught will be equals to 5 ohm and at 100 degrees Celsius it is 5.5. So I will apply 5.5 is equal to 5 into 1 plus alpha into 100. From there I will get the value of alpha. Then what I will do is at T degrees Celsius, which is the temperature of the hot tub, I will apply RT is equal to 5 into 1 plus alpha T. From here also I will get the value of alpha. I will equate these two equations and I will get the value of temperature. So temperature will come out to be 160 degrees Celsius. Okay. Now let's talk about electrical power. What is electrical power? Electrical power is basically the rate at which the energy is being created or the rate at which the energy is being destroyed. Okay. So two things are there. Whether any electrical device can either create energy, such as battery creates energy, it converts chemical energy into electrical energy, and one is that any electrical device is consuming energy, like capacitor consumes the energy and stores it, inductor consumes the energy and stores it, the resistor will also consume the energy but it will not store, it will convert it into heat and other forms of energy. So basically the rate at which electrical energy is created or consumed is known as electrical power. Achha, remember one thing, whosoever is consuming the power, that is called as load. The device or the electrical device which is creating the power, that is called as source. So basically source will be converting some form of energy into electrical energy. Like if you take solar cell will convert solar energy into electrical energy. If you will take chemical cell or battery, it will convert chemical energy into electrical energy. Now you have to remember one thing, that whenever there is a source, the current will always enter at the negative terminal of the source and it will always leave from the positive terminal. What will be the power delivered by the source? The power delivered by the source will be voltage into current. Voltage means the potential difference across this source multiplied by the value of current. When you talk about load, it will consume electrical energy and convert it into some other form of energy. Like basically resistor does what? It will consume the electrical energy and it will convert it into heat. So basically what will be the power consumed by the load? The power consumed by the load will also be equal to VI. So you have to remember only one thing, that power delivered by the source will be equal to voltage into current. The power consumed by the load will also be equal to voltage into current. The only difference is load is consuming that power and the source is delivering that power. The formula will remain same, that is V into I. Chalo, let's move to the next concept. If we talk about resistor, what will be the electrical power in the resistor? Always remember, resistor will always behave like a load. It will always consume the electrical power and that particular electrical power, it will basically convert it into heat. So that electrical power is converting into heat, so it will consume the electrical power always and convert it into heat. And always remember, whenever there is a load, in the load, current will always enter at the higher potential and it will exit at the lower potential. That means across a load, current will always flow from higher potential to lower potential. But across a source, current will flow from lower potential to higher potential. For resistor particularly, we already know that for any load, you can apply power is equal to V into I. But for a resistor, V can be written as I into R. So power can be written as I square R, or you can also write it as V square divided by R. So this is the power consumed by the resistor, power consumed by the load. Now how to calculate the heat dissipated by the resistor? So to calculate the heat dissipated by the resistor, if power is constant, the heat can be directly written as power into time, that is V into I into T, or I square RT, or V square by R into T. But if power is not constant, then you have to integrate it. The heat will be given by integration I square R into dt. There is one more unit of electrical energy. Electrical energy is given in joules, but 1 unit of electricity, whenever you take 1 unit of electricity, that 1 unit of electricity is in 1 kilowatt hour. That means if you operate your appliance having power 1 kilowatt, if you operate your appliance for 1 hour, then whatever energy it will consume will be 1 unit of electricity, and based on that you will pay the price. So 1 unit comes out to be 3.6 into 10 to the power 6 joules. I hope this concept is very much clear to you. Now let us come to the next concept, that is the concept of battery. Battery is basically what? Battery is a device which is basically converting chemical energy inside the material into electrical energy. So basically it is used to provide constant potential difference, and it converts chemical energy into electrical energy, and it is mostly used as a source. See, it can be used as a load also. When you charge a battery, it will be used as a load, but generally it is used as a source. And how it is used as a source? It will convert chemical energy into electrical energy. So there is some electrolytic solution and all these things are there. I am not going into the detail of that. You just need to know 2-3 things from here. First is you need to know the EMF of the battery. EMF of the battery is what? EMF of the battery is the potential difference maintained across the terminals of the battery when there is no current flowing through the battery. If the battery is in idle state, there is no current flowing through the battery, you have not connected any circuit, then in that case, whatever is the potential difference across these two electrodes of the battery is called as EMF of the battery. One more thing, when you will connect this particular battery with some resistor, or you will connect this particular terminals of the battery with the resistors, in that particular case what will happen is the current, the voltage across the terminals of the battery will reduce somewhat. Why it will reduce? Because outside the circuit the current will flow from higher potential to lower potential, but inside the circuit the charges will flow from lower potential to higher potential. When the charges will be flowing from lower to higher potential inside the cell in the electrolytic solution, when the charges will be flowing from lower to higher potential, then the electrolytic solution of the conductor will offer, or the electrolytic solution of the battery will offer some resistance, and that resistance is basically called as internal resistance of the battery or internal resistance of the cell. Because of this internal resistance, what will happen is there will be some amount of potential drop across this resistance. That is why in actual scenario, when the battery is connected to some external circuit, the voltage across the potential difference across the terminals of the resistor, or the potential difference across the terminals of the battery will be slightly lesser than the EMF of the battery, and that particular terminal voltage, that particular potential difference is called as terminal voltage of the cell. So 3 things you have to remember from here. One is terminal voltage, which is the potential difference across the terminals of the battery when external circuit is connected to the battery. EMF of the battery is the potential difference across the terminals of the battery when no external circuit is connected to the battery and the current is not flowing. And internal resistance is basically the resistance offered by the electrolytic solution of that particular cell. The internal resistance actually depends on few factors. The internal resistance depends on the separation between the plates. It is directly proportional to the separation between the plates. It is inversely proportional to the area of the plates, and this will be proportional to the concentration of electrolytic solution. If you will take a highly concentrated electrolytic solution, then the resistance will also increase. It is also inversely proportional to the temperature of electrolytic solution. Always remember, internal resistance of the cell is inversely proportional to the temperature of electrolytic solution. But the resistance of a conductor is directly proportional to temperature. As temperature increases, resistance will also increase. But internal resistance is inversely proportional to the temperature of electrolytic solution. So I hope this point and all these things are clear to you. How to represent a battery? If there is an ideal battery means what? Ideal battery means there will be no internal resistance. There will be no internal resistance. Now tell me one thing. If you will consider an ideal battery which is not having any internal resistance, then can I say that in that case, whatever will be the terminal voltage, that will be equals to the EMF of the battery? Yes, we can say that, because in that particular case there will be no potential drop across the resistance because there is no internal resistance. That is why for ideal battery, EMF and terminal voltage are one and the same thing. How to represent it? It is represented by this symbol. There is one terminal and there is small terminal. The bigger terminal is positive, the smaller terminal is considered as negative, anode and cathode. If you will take a non-ideal battery which is having some resistance, then there will be some internal resistance which will be offered here. I hope this point is also clear to you. Chalo, let's move to the next concept, and the next concept is basically this. I think I have already told you what is the EMF of the battery, how the battery is behaving as source. Always remember, the battery, if it is behaving as source, then the potential difference across the terminals of the battery will be given by E minus IR. Okay, delta V across the terminals will be given by E minus IR. Here I already told you that IR is basically the potential drop due to the internal resistance of the battery. So whatever potential difference will appear across the terminals will be EMF minus IR. In the same way, if the battery is working as a load, then in that particular case, the terminal voltage will be equals to E plus IR, because now the battery is charging. Now the battery is not delivering energy, it is basically taking or consuming energy. So in that case, the potential difference will be equals to E plus IR. So these concepts I have already told to you. You can just revise this and you can take the screenshot. Now, what is the meaning of short circuit? What is the meaning of short circuiting a wire? Short circuiting means if you are having a resistor and across the two ends of the resistor you connect a wire which is having zero resistance, then in that case what will happen is the potential difference across the resistor will become zero and the entire current will actually go through this particular wire. So short circuiting two points A and B means that the connecting these points A and B by a wire of zero resistance. So obviously whenever you will short circuit a resistance, the entire current will flow through this particular wire. There will be no current which will be going through this resistor. Next, short circuiting a battery. If you short circuit a battery, that means across the terminals of the battery, if you will apply some wire, then there will be no, the current will flow through this particular element. And what will be the current of this? Current will be equals to E divided by small r. EMF of the battery divided by the internal resistance of the battery. The terminal voltage will become zero here also. If you open circuit a battery, there will be no current, and in that case, the EMF will be equals to the terminal voltage. I already told you in this case that whenever we talk about the case of idle state, where the current is not flowing through the battery, in that particular case, always remember there will be no current and the potential difference, the terminal voltage will be equals to the EMF of the battery. So if there is no current through the battery, then EMF of the battery is equal to the potential difference across the terminals of the battery. I hope it is clear to you. So these were basically the concepts related to cell, battery, EMF, internal resistance and all these things. Now, if I connect battery with the external resistance capital R, then what will be the power delivered to the load or power consumed by the load? The power consumed by the load will be equals to E square divided by capital R square, capital R plus small r whole square into capital R, that is I square into capital R. Now this power, if you will see, if you will draw the graph of power versus capital R, you will see that at a particular resistance, when the external resistance of the circuit becomes equal to the internal resistance, the power consumed by the load is maximum. This concept is called as maximum power transfer theorem. Always remember, in maximum power transfer theorem, whatever variable load, the load which you can vary, whatever variable load you have applied across the terminals of the battery, that particular resistance should be equal to the internal resistance of the battery. If this condition is matched, then the power consumed by the load will be maximum. So this is called as maximum power transfer theorem. It is a very important concept. I have derived it here. If you want, you can take the screenshot. I have already explained you the main concept, that the power will be maximum when the external resistance which you have applied across the load is equal to the internal resistance. So I hope this point is also clear to you. Now let's go to the next concept and let's do some questions based on KVL and KCL. See, it's better that you take these questions and you apply concepts on this. Okay? KVL and KCL is a very easy topic. KCL tells you what? Kirchhoff's current law tells you that if you are having a junction or a node, then whatever current will be entering that junction will be equal to the current which is leaving from that junction. So summation of currents entering the junction is equal to summation of currents leaving the junction. And what will be the, on which law this particular KCL is based? KCL is based on the principle of charge conservation. It is based on the law of conservation of charge. So based on this, some questions are there, you can try. And let me tell you about KVL also. Kirchhoff's voltage law is what? Kirchhoff's voltage law is also called as loop law. It is telling you, it is basically based on energy conservation. It is based on the law of conservation of energy. So if you take one point, suppose you are having a loop here, है ना? Suppose you are having a loop here, and different electrical elements are there in this loop. You have different electrical elements in this loop. So what will happen is, you will start from one point, you will go across the loop, and whatever potential differences you are getting, you might be getting potential drop also and you might be getting potential gain also. If you are going from higher potential to lower potential, it will be potential drop. If you are going from lower to higher potential, it will be potential gain. So suppose you are starting from here, plus minus V1. So plus to minus you are going, that means potential drop. So you will write minus V1. Then you are going from minus to plus. So you will write plus V2. Then minus to plus, so plus V3. Then plus to minus, minus V4, and that will be equals to 0. So always remember, whenever you are moving across a closed loop, what you have to do is you have to do the summation of all the potential drops and the potential gains. Potential drop means higher to lower potential, you will take it as negative. Potential gain means lower to higher potential, you will take it as positive. So summation of all the potential differences will be equals to 0. Delta V summation Vi will be equals to 0. I hope this particular concept is clear to you. Always remember, KVL is actually based on what? It is based on the law of conservation of energy. Like, let me take one example here. Suppose I have taken a very simple example. Let us take this example, it is somewhat better. So let us suppose there is a 20 volt battery and there is a 10 ohm resistor, 3 ohm resistor, 7 ohm resistor and 70 volt battery. And you are asking the current in the circuit. So how we will do this particular question? Very simple. You can move from anywhere. Wherever you want, you can move. So let us suppose the current is in the clockwise direction. What you will do is, suppose I move from here. Okay, I will move from here. So as I am going here, plus to minus I am going, so I will write minus 7i. Because the drop will be I into R na, minus 7i. Then minus to plus I am going to plus 70. Plus to minus I am going minus ka 10i. Plus to minus I am going minus 20. Plus to minus I am going minus 3i, and I will get it as 0. Solve this particular equation, current will be coming out to be 2.5 ampere. So this is how basically you can apply KVL to different branches. Okay. So this point is also clear to us. Now let us go to the next concept, that is series and parallel combination. This I already told you somewhat in the case of capacitor also. Let me just quickly revise it here. In series combination, always remember the current remains same and the resistors are joined end to end. The current should be same, the resistors are joined end to end, then we will call this combination as series. In series combination, R equivalent will be equals to what? R equivalent will be equals to R1 plus R2 plus R3. In series combination, the voltage across the different resistors will be proportional to the resistance. V will be directly proportional to R. So V1 is to V2 is to V3 will be R1 is to R2 is to R3. One more thing, what will be the power dissipated in these resistors? The power dissipated will be I square R1 for this. For next it will be I square R2 and like this. So net power will be I square into R equivalent. So this is basically the concept of series combination which you have to remember. If you go to the parallel combination, then what will happen? In the parallel combination, the potential difference should be same across all the resistors. Parallel combination will be decided by the potential difference. So if the potential difference across all the resistors is same, then we will say that this is a parallel combination. For parallel combination, the equivalent resistance will be 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. The current will be inversely proportional to R. So I1 is to I2 is to I3 will be 1 by R1 is to 1 by R2 is to 1 by R3. If two resistors are connected in parallel, then in that case, the equivalent resistance will be R1 R2 by R1 plus R2. And suppose if you want to find the current, you can find the current now, because I1 is to I2 will be equals to what? R2 by R1. Yes or no? Inverse relation is there. So I1 will be equals to what? R2 divided by R1 plus R2 multiplied by total current. I2 will be what? I2 will be R1 divided by R1 plus R2 multiplied by total current. So this is how you can find the value of currents in parallel combination. I hope this point is also clear to you. So these were series and parallel combination. Now if you want, you can do a lot of questions based on that. Like I have taken few questions, you can take the screenshot and you can practice these questions based on this. So please take the screenshot. Solution also I have written, please mark this and you will get the answers. So you can take the screenshots and you can try these particular questions. One concept is there which I must tell you, that is called as Wheatstone bridge. What is the Wheatstone bridge? Please understand. Wheatstone bridge is basically having 4 terminals. These are the 4 terminals which I am talking about, and it contains 5 resistance. So if this type of setup is there, then this particular setup is called as Wheatstone bridge. In the previous capacitance also I gave you this logic. Here you have to just remember that if R1 by R3 is equal to R2 by R4, then we will say that the Wheatstone bridge is balanced. And if the Wheatstone bridge is balanced, then across these 2 points, the potential difference will be 0. If the potential difference is 0, there will be no current in this, current will be 0. And in that case, you can remove this particular resistor. And if you will remove this resistor, then what will happen? These two will come in series, R1 plus R2. these two will come in series, R3 plus R4, and the combination will be in parallel. So you can easily calculate the R equivalent of the circuit. So this condition is called as balanced Wheatstone bridge condition. So based on that also I have taken some questions. Please take a screenshot and try these questions on your own. Okay, let's move forward. Then comes the concept of combination of cells. So in combination of cells means what? If you are connecting cells in series, or you can connect cells in parallel. If you connect the cells in series and both are having same polarity, that means due to both the cells the current is going in the same direction. Due to this cell also it is going in this direction, this cell also is going in this direction. Then E equivalent will be given by what? E equivalent will be directly the addition of the individual EMFs E1 plus E2, and R equivalent will be R1 plus R2. And you can replace this particular cell combination by a single cell whose E equivalent is E1 plus E2 and R equivalent is R1 plus R2. If polarity of any one cell is removed, or if polarity of any one cell is reversed, in that case what will happen is, whenever you will reverse the polarity, then whosoever's polarity you have reversed, you have to take negative sign there. So here E equivalent will be equals to E1 plus E2 minus E3. R equivalent will be equals to R1 plus R2 plus R3. Achha, one more thing please remember, very important point. If suppose you have n cells and all the cells are having EMF E and internal resistance R, and they are connected in series in same polarity, then what will happen? Very simple. If you have n cells and all are having same polarity, then equivalent EMF will be what? E plus E n times. That will be NE, and similarly the internal resistance will also be equal to NR. And one more important point, that if n cells are connected in series with negative terminal of one connected to the positive of other and so on, if polarity of m cells are reversed, then find the equivalent EMF. So out of n cells, if you have reversed the polarity of m cells, then what is the equivalent EMF? So this also is very clear, that because you have reversed the polarity of n cells, then whatever are the cells which will be in the same polarity will be n minus m. So E equivalent will be n minus m multiplied by E. They are in same polarity, but you have reversed the polarity of m cells, so you have to subtract also. It will be minus me, so it will come out to be n minus 2m multiplied by E. This will be my E equivalent. I hope this concept is also clear to you. Next, in parallel combination, what will happen? Please understand. In the parallel combination, if the cells are connected in parallel like this, having same polarity, then E equivalent will be given by what? E1 by R1 plus E2 by R2 divided by 1 by R1 plus 1 by R2. And R equivalent will be given by parallel combination only. 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Again, if polarity of one of the cells is reversed, then you can subtract that particular polarity, you can take the negative sign. So I hope the series and the parallel combination is also clear to you. Now let us go to the last concept of this particular chapter, that is meter bridge. Meter bridge is basically an experimental setup which is based on the condition of balanced Wheatstone bridge. I already told you balanced Wheatstone bridge. So meter bridge is basically based on the condition of balanced Wheatstone bridge, and mainly it is used to find the unknown resistance of the cell. So to find the unknown resistance, we use meter bridge. So basically what happens is, this is the typical setup of meter bridge. Here there are some metal electrodes, the metal connectors are there like this. On between two metal connectors, we will put a known resistance. Between the other two, we will put an unknown resistance. Here we will connect a 1 meter wire. This is a uniform wire, means having uniform cross section. Its length is 1 meter and its alpha is generally less. The coefficient, the temperature coefficient of resistance is less. Why it is less? So that after flowing current, if the temperature increases, the resistance should not change much. There is a jockey here connected with a galvanometer. You will slide the jockey from one point to another point. You will slide the jockey from one point to another point and you will note the null deflection. Wherever null deflection is happening, that point is called as a null point, and this length, wherever it is happening, this length is called as the balancing length. So if you will draw this particular setup in the form of Wheatstone bridge, what you will get? Between these two terminals, there is a known resistance R. Here there is an unknown resistance X. Here this part of the wire will have resistance rho L over A. This part of the wire will have resistance rho 100 minus L over A. And this will be the galvanometer whose current is 0 because I have obtained null deflection. So obviously Wheatstone bridge is balanced. So I will divide these two resistance and I will get the answer. The unknown resistance will be R into 100 minus L divided by L. And from this formula, you can easily get the value of X, because L will be the balancing length that will be known to you. You have done the experiment, you will know the balancing length. So you will get the value of x as r into 100 minus L divided by L. So I hope this all concepts were clear to you. I have discussed the majority concepts, some questions also I have discussed, so that this particular concept was clear. So we'll meet in the next video with another chapter. Thank you very much.